Here it's asking us to apply information about Ka values to compare the strength and reactions of acids and bases. So I'm going to click back and forth to the notes to see our values as well. It gives us chlorous acid, which is 0.011 in terms of a Ka, and formic acid, which is 0.00018. So in that case, chlorous is significantly stronger or has a significantly higher Ka value. So the acid-base reaction of these would mean both of them are put in together. One of them is better at donating its hydrogen, whereas one is worse. We looked at this previously with HBr and HI, and hopefully after watching the videos about molecular structure, you understand why HI is now stronger. But this gives it away, and this accepts. That means that this would be acting as our acid. Down here, it asks the equilibrium reaction and the base ionization expression for fluoride acting as a base. What is the Kb? I did not do that. And now, magically like that, I did. Fluoride acting like a base would be fluoride ion reacting with water to turn back into HF, producing the OH minus ion. If the HF is a weak acid, that means F minus is a weak conjugate base. So there's the reaction. The Kb tells us how strong is that as a base. Right here, we would see that Ka times Kb is always equal to Kw at 25 degrees Celsius, which we assume, unless told otherwise, Kw is 1 to the negative 14th. When we solve for this, we see that it's a very small Kb. So although it is a weak base, it is a very weak base. On C, we apply that right away. Which of these is a stronger base? Ammonia. And ammonia's Kb is 1.76 or 1.8 times 10 to the negative fifth. And that is not just a little bit higher, that is much higher than the Kb for the fluoride ion. So ammonia is much better at accepting a hydrogen than that fluoride ion is. When we're looking at comparing carbonate to bicarbonate, we see carbonate is 1.8 to the negative fourth. Bicarbonate is 2.3 times 10 to the negative eighth. A very big difference in K value. The K value supports that. The reason why, as described here, is it's how good is it at attracting a hydrogen ion. It has to do with the fact that this has, quote, more space, but more importantly, more attraction for that hydrogen. That -2 charge is a stronger attraction for that +1. So this can attract and hold in another hydrogen, but not quite as well as this one.